Hi everybody, this is Gigi from Kauai Community College. This is an application on the L'Hopital's rule. Okay, so remember, L'Hopital's rule said if you have limit of the, where you will have the form 0 over 0 or plus or minus infinity over infinity, then you can apply the L'Hopital rule, right? And the rule said that the limit as x goes to a of the function f of x divided by the function g of x is going to equal to the limit as x goes to a of the derivative of the numerator divided by the derivative of the denominator. Okay, so when looking at this problem here, we will see that when x is approaching limit as x goes to 0 from the right of x multiplied by not cosine but cosecant of x, we can see that when we are approaching x 0 from the right hand side, your cosecant goes to infinity. So then we will have this of the form 0 multiplied by positive infinity. Okay, now that is one of the indirect application of the L'Hopital rule. Now what I mean by that is if we can put that in this form somehow, then we can apply the rule. So let's think about cosecant. Limit as x goes to 0 from the right. Now why am I talking about the right and the left is because when we are approaching 0 from the right, cosecant goes to infinity, and then when we are approaching the left, the cosecant goes to negative infinity. So I wanted to make sure that the limit goes from both directions is going to go to the same number before I can conclude that the limit as x go to 0 of this thing is certain of a value. Okay, so let's go ahead and apply L'Hopital rule, meaning take the derivative of the numerator, which actually I'm going to transform the way this looks to make sure that it's of this form here. So this would be x divided by cosecant is 1 over sine of x. So when we do this, we actually say we have the form 0 over sine of x. Sine of 0 is 0 as well. So it is now of the form 0 over 0, and L'Hopital rule will apply, which means that this right here is going to be equal to the limit as x goes to 0 from the right of 1 over cosine of x. And cosine of 0 is 1, so we actually do have a value of 1 when x is approaching 0 from the right. Okay, now we want to make sure that when we are approaching 0 from the left, that it is also going to be 1, otherwise it doesn't have a limit at 0, right? Left hand limit and right hand limit has to be the same. Okay, so it's same thing here. I have 0 multiplied by a negative infinity, because when we are approaching x from the left, our function goes down to negative infinity. The cosecant is, right? So we need to rewrite this as x over sine of x. And again, the L'Hopital rule now will apply because I will have the same form 0 over 0. So then when I am approaching x from negative infinity, I can take the derivative of the top, which is 1, derivative of the bottom, which is cosine, and we still going to have 1. Therefore, left and right hand limits are the same. Then I can say that the limit as x goes to 0 of x multiplied by cosecant of x is equal to 1. And I would say that is that limit. Okay, so when it's not of the form that we are allowed, we need to rewrite it so that it becomes the form that we could use.